Okay, section 10.2, all about congruent chords, and guess what? You get more proofs to do. Aren't you excited? I know you are. Okay, here we go. Theorem 77. We're talking about two chords of a circle being equidistant from the center, and if we know that, then we know that the chords are going to be congruent. So remember how we show distance away is along perpendicular segments, right? So not only do we need to know that they're equidistant, but in order to know that they're equidistant, we would also need to know that these are perpendicular segments. Okay, so that has to be established, either given to you or through the course of the proof. So once you know that these are perpendicular, and you know that GA and AF are congruent, because that's going to show the same distance away, right? Then you would be able to say that DC is congruent to BE. And of course, in our proof, we're going to shorthand this by saying if chords equidistant, then chords congruent. Okay, so that's the first theorem for today. The second theorem is basically the converse, that says if you know two chords are congruent to each other, then you know they are equidistant from the center. So once again, if you know that the two chords are congruent, then you'd be able to say that GA is congruent to AF. And of course, you would have to know that these are perpendicular as well. Okay, and then the reason that we would use in our proof for this one is really just the converse of the above statement. If chords are congruent, then chords are equidistant. Okay, so let's put this to use and see how it works in a proof. Here we go. So we're given this circle, and the center is P. They tell us that PR is perpendicular to WX, and PS is perpendicular to XY. So let's go ahead and mark that in our proof. So that's perpendicular, and that's perpendicular. Ooh, that was terrible. Let's try that again. Okay, so let's see if I can do a better job. There we go. Okay, so this is what we know, and we also know that PR is congruent to PS. So PR and PS, oh, look at that. They've given that information to us as well. Lovely. So we know this and that are congruent. So they've basically solved the whole problem for us. We are trying to prove that angle W, this angle right here, is congruent to angle Y right there. So if we look at this diagram, we have a triangle. We have this big triangle right here. And if there was a way to get WX and YX congruent, then we could do if sides, then angles. So if we look, WX and YX, those are chords. And because they've already given us that these are perpendicular to the chords and they are congruent, they've basically given us everything to be able to say that the chords are congruent using our new theorem, that if chords congruent, then chords are equidistant. So, oh, I got that one backwards, didn't I? Fudge. Okay. Here, let's see if I can do it. Okay, look at that. I was able to fix it without having to restart the whole thing. Lovely. Okay, so please note that I have changed this into the correct format, that if the chords are equidistant, then the chords are congruent. Okay, so now that we know that those chords are congruent, now we can say that angle W is congruent to angle Y because if sides, then angles. Okay, there we go. This was a nice short little video for you all. Wow, only 4 minutes. You guys lucked out.